For this problem, we have a double sum, summation I equals 1 to 2, summation j equals 1 to 3, I minus j. Now for this one, and any double sum problem that will come at you at this test, the numbers are sufficiently small that just simply plugging in numbers will do the trick. So let me do it the simple-minded way first. So if I just simply plug in numbers, I equals 1, I equals 2, those are my two options for I. And for j, we have three options, j equals 1, j equals 2, and j equals 3. So let's figure out I minus j. So 1 minus 1 is 0, 1 minus 2 is negative 1, 1 minus 3 is negative 2. 2 minus 1 is 1, 2 minus 2 is 0, 2 minus 3 is negative 1. And so if we just simply add these things up, summation I equals 1 to 2, summation j equals 1 to 3 of I minus j will be the sum of these six things. So 0 minus 1 minus 2 plus 1 minus 0 minus 1. And those cancel, these two cancel, so I end up with just simply negative 3. And that's the answer. And for the purposes of this test, that would be sufficient. Now for the sake of completeness, I just wanted to show you a different way that this could be done. It certainly takes a little bit more work than what we just did, but the method that I'm about to show would work even if the numbers here were not small but were substantially larger. So here's the general way of doing this. And again, I mentioned this by way of completeness. For the purposes of the exam, I wouldn't hold you to this, but I at least want to mention it. Okay, so let's split up the double sum, just like we can split up single sums. J equals 1 to 3 of I minus summation I equals 1 to 2, summation j equals 1 to 3 of j. Okay, now let's see, what do we get here? For this inside sum here, j changes, but I does not inside of these brackets. Inside the brackets, j changes from 1 to 3, but I does not. So this is going to be I plus I plus I, so that's going to be summation I equals 1 to 2 of 3i, adding I to itself 3 times. Over here, summation I equals 1 to 2. Here, summation j equals 1 to 3 of j. Now this I can directly add up. 1 plus 2 plus 3 is 6. Alternatively, I can use my j n times n plus 1 over 2 formula to figure out this sum. That works out to be 3 times 4 over 2, which is also 6. Okay. Now here, if I equals 1, I get 3. If I equals 2, I get 6. So this works out to be 3 plus 6. Alternatively, we could use the n times n plus 1 over 2 formula again. On this one, it's going to be 6 times 2, because this is 6 plus 6, the 6 added to itself twice. So we end up with 9 minus 12, which once again works out to be negative 3. Now that's a fair amount of work, and for this problem, just simply listing out the 6 possibilities is certainly the faster approach. But I did want to mention, just at least in passing, that it is possible to work with double sums in the same way that we work with single sums, so that these things can be evaluated without being forced to list out terms.